Going want one?
Oh shit.
No, all right. Did you go to Wendy's to support the fundraiser thing? Or did you just go to Wendy's because you wanted nuggets?
There's a fundraiser?
There's a fundraiser going on today through Grossmont's business office, whatever, technology.
Oh, no, I just...
So you,
yeah,
oh man,
it's strange.
your nuggets could have been an act of generosity.
Well,
Instead, they were just,
yeah, they're benefiting me.
there you go. I'm generous to myself.
He broke Nug with us.
Huh?
He broke Nug with us.
Oh, I broke nug. It's so nice. The old Russian thing about nuggets and salt. No? Okay.
Yeah, I was over my head.
Really? Bread and salt is what you bring when you break bread with your neighbor or something for Russian guy. So if you weren't here last time, I feel very bad for you because we did some nifty stuff. We talked about Egyptian numerals, for example. And we talked about Chinese numerals.
And Greek. No.
We didn't talk about Greek, and actually we're not going to talk about Greek for whatever reason. We just don't. Roman numerals, there you go. Cool, I like it. So somebody remind me, what is it about Roman numerals? So if I wrote this up here, what do you scan through there for first?
See if there's any smaller ones before bigger.
Kick ass. See if there's a pair where there's a smaller one from a bigger one. You do have to memorize what each of the Roman numerals are because I have them memorized, right? So you have to know what I is, and X, and V, and L, and C, and M, and D. You with me? If you don't currently, you still have time. So get that memorized, or don't. So what pairs do I see here that's got a smaller in front of a bigger? Yeah, XL and CM. Kick ass. I like it. So M is
500, 1,000.
there. It is 1,000. Yeah, C is 100 and M. So it's C from M. So it's 1,000 minus 100 there. X is 10. So it's 10 from 50. And then that is just what? 6. I like it. Cool. And then you just put those back together. All right. So there's really, you got to memorize the symbols. Guys, thank you so much. You got to memorize the symbols, and then there's a couple rules. If there's a smaller symbol in front of a bigger one, they subtract. And what was the other rule?
No more than 3.
Beautiful. You can't have more than 3 immediately in a row. And more than 3 of the same symbol. I like it. So, what's wrong with this?
It's too small to subtract from the C.
That's one thing. So I got, you got 1, 5, 10, 50, and then 100. So one thing is you can only take one away from,
The next two.
5.
or yeah, exactly. I like it. So that one thing is that's wrong is it's trying to go too far. But also, what else is wrong with this? So even if I did this,
You have too small before a larger?
exactly, I can only have a pair with a smaller in front of a larger. With me. So what number are they trying to do? What number is this trying to be?
98?
Yes, that's not. So what's the right way to do 98? I got to make a what and a what?
X
A 90 and an 8.
So XC.
I like it. So 90 is 100 minus 10. So XC, I like it. B. Aye, aye, aye. So there's 90.
Yes.
I was wondering if somebody would do. There's 90 and there's 8. I like it. How we doing? So that, you've got to pretty much memorize the Roman number system. All right. Good luck with that. Egyptians, I'm not going to make you memorize the symbols. Bless you, bless you. Okay. 3 means money, so I was hoping for you. I don't know if you knew that. 3 in a row means money. Egyptians are not going to make you memorize those because I don't have those memorized. So I'll give you those, a printout of those for the test. You'll have that sitting next to you. Their system is remarkably simple. They just put, so if they had this here, I just have to know what these symbols mean. So that would be 3 somethings. Yeah, good, 300.
10.
So 10, 10, 10, 10, 40. 2. Yeah, so Egyptians are a remarkably simple system, which means they're going to run into trouble because the more simple your system is, the harder it is going to be to do certain things. The Romans made rules so that larger numbers were easy to write, for example. I like it. And then the last thing, let me see, that we talked about last time, I think we got a little bit in the
To Chinese.
Chinese.
Yeah.
And the poor Chinese, I was making fun of it. I wasn't really making fun of it. The symbols certainly have certain looks to them. Sort of like Rorschach tests where you... Now I'm thinking about Watchmen. If I draw... Well, especially if I draw it. If I do this here... And then this... So the main idea behind the Chinese is it's a multiplicative system. Or at least it used to be. I think now they use the same symbols that we use. Say again?
I think it's 7, right? I mean 7?
Which one?
That one right there.
No.
7 there.
This is trying to be a 4, and this is trying to be 1,000. Now I'm not going to claim that I draw these well at all. So this would mean 4 times 1,000 so far, right? So the idea is what's important right now, because the symbols you're not going to have to memorize. I'm not going to make you memorize Chinese symbols. You just have to memorize how it works, how they put numbers together. So if I want to say 4,500, there's 5. 100 is the little light. Well, now I look at it as a helicopter, but no well. 500, and so forth. You guys kind of...
So it's every 2, and then you add them?
Exactly. So these together, every pair makes, like, we would say 4,500, right?
You get to make 4,000.
4,000, that's a pair of symbols for them. 500, that's a pair of symbols for them because they didn't have the idea of putting a number in a place, and that place inherently meaning 1,000 or 100. That was a huge step forward in thinking of a different way to do numbers. Are you guys... Anyway, so you guys were born at a time when a lot of work was done already. You just brought up it and you don't even realize how much work went into it.
How do they say 1?
Well, 1 is just this.
Oh yeah.
And then 2 is 2, and then 3 is 3, and then thankfully they stopped doing that because that'll get a little hard to know on sight.
So do you always add everything in pairs?
I like it. So it's multiply and then add. Right? So this would be 4 times 1,000 plus 5 times 100, and then more if there's more, yeah.
So then
So
it's...
multiply it then.
Exactly. So instead of, what is our system, why is that a 4,000? Because it's in the thousands place. Why is this a 4,000? Because it's 4 times 1,000. It's got 1,000 symbol after it, so that's what makes it 4,000.
So it's 10 times 1? The 10 symbol and the 1 symbol?
No, 10 is just 1. So if I want to say 4,510, that'd be 110.
Okay, that's...
Right? That's 110.
Right.
And then if I want to say 4,517, because 7's the symbol I know, because it's the lazy T.
So there's a singular symbol for 1 through 9?
Exactly. Kick ass. Because it would be kind of silly to say times 1. They realize at the end you just needed 1 symbol. I like
3
it.
times 3.
No, thankfully they don't do that. So the only thing you multiply by are the multiples of 10. Just like our places only mean multiples of 10. So they had the idea that our number system does. They just hadn't come up with the shorter, quicker way to write. They thought I had to multiply by 1,000. You got it with me. So, but the one thing they have over us is how many symbols do they need to write 4,000? 2. How many symbols do we need?
4.
Oh, okay. So there's a few places where it's a little better, maybe.
Yeah, we can do it in 2.
We could do it in scientific notation, whatever. How are we doing so far? So you guys get the idea of the Chinese number system, because I'm not going to make you memorize the symbols. You just have to know how to put things together. I like it. So here, let me let you guys try one. We put the symbols up here. So this works.
And will be in history books?
So it's written top to bottom.
Exactly. It's written vertically. Kick ass. We're going to see later that the Mayans also wrote theirs vertically. So part of the test, if you don't write it vertically, you're going to lose some points. So I want you to write it the right way.
And you don't write parentheses like you did, you just leave it without the parentheses?
Yeah, I just put those in just to group them
Yeah.
visually. Yeah. But you're right. You wouldn't normally have that. Oh, yeah. That looks great. So if you have your book, this is on page 173. Yeah. Look at that. Alright, so let me ask you guys to do some. So I want to put the symbols up here. I think you need to see all that. Oh, again, it's still got that weird. Okay. Alright, so that's what you need right there. Alright, so now I want you guys to try to write these numbers using those symbols. So write those two numbers using the Chinese symbols. So if you are as bad an artist as I am, thankfully the symbols are pretty distinct. You'd have to draw exceptionally bad for me to not be able to distinguish, the symbol for 5 from the symbol for 9. I have to be able to distinguish them. So.
Is that
Yes,
a
sir.
challenge?
If you want to take it as such, then you can lose points.
What about the composition of the two numbers being multiplied? Does the bigger number need to come first or your subsequent?
No. I want this to make sense. The second number is always the place it's in. So it's 4,000, exactly the way we would read it. So the second number in the pair is always going to be the place that that first number's in. Sorry. So these two numbers. Oh, there it is. All right. So we got that? If you don't have it yet, then it's a bad sign. You got it or you don't. So 917. So the symbol for 9, what's that look like? What do you think? It's hard to tell. 900. Helicopter. Right? 917. So I need 900, 110, and a 7. Right? So you can always write this for yourself. I need 900, 110, and a 7. That's what goes into 917. So 900, 110, and 10 is nice. It's T, right?
What if I did 2, 8, and then 1 at the end?
No, see that? No. I like it. So it's not base 8, it's base 10. So your multipliers have to be big, 10s. You with me? Just like our places mean multiples of 10, their multipliers have to be multiples of 10.
Alright.
I like it. Otherwise, there would be an infinite number of ways to write certain numbers as, okay, we can't do that. It's a little crazy. What am I missing here?
7.
Yeah, so the lazy T for 7. I like it.
Can you
So
tell if
that
I
would-
did it wrong, or you just draw weird symbols?
I might have drawn real similar. My 9 looks a little crazy, but otherwise it's all right. 900, 110.
It's the 100 that looks weird.
Oh,
The 100 is just the T.
no, the 100 is the helicopter.
It's a square with a line.
Yeah, it's a square with a line in it.
And then a line on top.
Yeah. Oh, I think I drew
Yeah.
this thing in the wrong place. There. Is that better? A little bit?
Looks
Yes,
like-
ma'am.
So that whole answer would be those.
Yes, so this would be the answer for the first problem. I like it. So what about this guy? I need 5,000,
1,000. 3.
300, 4 tens, and an 8. Where are my students from China? Any students from China? You're from China? No?
North Korea.
What's up?
North Korea.
We made it out.
China.
That's okay.
I just always, last semester I think I had a student from China and they verified that not the way I draw it, but the symbols were actually correct. 5, I call 5 the rocking chair. 1,000 is just that weird looking 7 dude. 300,
4 is the 2B.
4 is the TV with the sock show on.
I feel like it looks like a dude like lynching himself.
4T, I love the symbol for 10.
The
4T
little feet.
looks like a dude punching himself.
No, lynching himself.
Oh, lynched
It's like
himself.
the
All right,
paid
I always think the same thing, but I decided not to say that. That's a horrible show to watch. Just these feet swinging.
Did
You know, you don't like Hitchcock?
and 100?
Say again.
Did you forget the 1,000 and 100?
There's 5,000,
Oh, okay.
300,
Mhm.
4T, 8.
Oh,
Eight's
I was
the-
looking at the wrong thing.
It's
Okay.
eight's the eight's
I like
something like that. Yeah.
Backward silence. Crappy triangle. Either one of those.
Conceptually crappy triangle. It's missing a side. It's missing the whole reason it's got a try in the name. It's horrible. Okay. All right, so let the Chinese system be simple, especially because I'm going to give you the symbols. I'm not going to make you memorize the symbols because I don't have them memorized. Okay, so what I want to focus on today is getting into section 4.2, maybe even 4.3. We'll see how it goes.
Alright, let's get some eyes.
Dude. So 4.2 is starting to get closer to our system, believe it or not. We're going to get into the systems that have place values. And the first one is exceptionally weird. The Babylonians. Oh, you missed all that, that's right. I don't think it's
The land of triangles.
So the Babylonians, they're actually where we got our ideas for how we break up time. We break up time hours, we break them up into how many minutes, and then we break those up into 60 seconds. I don't know if you guys know this, but we also use the same thing for latitude, longitude. We have minutes and seconds in latitude and longitude. I don't know if you guys knew that. So the Babylonians, we use base what? What base do we use?
10.
10. The Babylonians used base
60.
60.
That's a big base.
What's really nice about the number 60? Think about it. What's really nice about the number 60?
It's even.
It's even.
You can break it down into 10.
You can break it down in a lot of different ways.
Divisible by 2 and 3.
It's divisible by 2, 3, 4, 5, 6, 10, 12. It's divisible by a lot of shit, right? Say again?
7.
Not quite. Not even on a good day. 7 can't
On
go.
a bad day.
7 goes into 63. Well, on a bad day, it's given. It ain't gonna work. I said not even on a good day.
I had too many nuggets.
All right, you guys. Now watch. Let me just show you how base 60 works on its own, and then we'll introduce the symbols that the Babylonians used. Right? Moderation is key. So help me out here. Our system base 10. What does that mean? So like this, the number 417, what place is this in? The ones. Otherwise known as the 10 to the zeros. Because what's anything to the 0 power?
1.
1. Yes, I like it. Cool. Algebra. Oh shit. Sneaks in every now and again. The next place is the...
10.
No way. So that's 10 to the first. Tens. And the next place is the hundreds. 10 squared. Right? Maybe I should do that the same way. So the next place would be incredibly enough, 10 cubed, so forth. So if I had base 8, what would it look like? The 1's place, the 8's place, the 64's place. Oh shit, that's going to be the next section. Let's focus on Babylonians. They use 60s. So what place is this?
6.
The 1s. It always starts at the 1s. You got to have a 1's place, or else you can't represent the number 1. What about this place? 60s. What about this place?
60 squared.
60 squared, which is also known as?
3,600?
Yes, which is the number of seconds in an hour.
What?
60 seconds in a minute, 60 minutes in an hour, 60 times 60, 3,600 seconds in an hour.
So
Crazy. Yeah, that's right.
cubes is how many hours a
Math.
day, right?
What's again?
So 60 cubes is a day then, right?
No, unfortunately not. 60
Ah.
hours in a day?
Yeah, right?
I don't know. Some days you don't want to be 60 hours long. So before we do the symbols, let me just show you. So I'm going to still use our symbols. What if I had, I don't want to know. Well, sure, why not? 417. What number would that actually be? Here it's 417. We can look at it and know exactly what it is. Here it's not 400s, it's 4 3600s. So how do I put this number back together? Well, I do 4 3600s plus 160 plus 7 ones.
What? Well, I mean, I get it, but
That's exactly what we do here, isn't it? What's this number? 400s plus 110 plus 7 ones. That's why it's 417, because we use base 10. They used base 60. Each of their places are based on the number 60. So if they had a symbol here that meant 4, it's in this place. That means it has 4 of these. 1 of these, 7 of these. So what number is this actually? Somebody doing that for me?
1, 4, 4, 6, 7.
1, 4, 4. Oh yeah, good. All right, that makes sense. Now they didn't use our symbols, of course, because our symbols were developed over a long period of time after they were gone, so forth, right? Starting around when they were there. They used their own symbols based off of this tool they had to stamp into clay tablets, and the end of the tool looked like this. So they said, okay, let's make some symbols based off of that. That makes sense. We don't have to make any new shit. Let's just do that. So what they did, so let's marry the fact they have the base 60 and their symbols. I think I already showed you this, but technically their symbols look like this here. Let me see if I can represent this right. That and like this. But I just make it this and that, just for writing it very quickly. We don't have clay tablets. I'm not expecting you to create a Babylonian clay tablet stamper. I'm not going to make you make that. If you want to make that, do it in your own time. So we're just going to represent it like that. This, I don't know if you guys remember, this meant
Subtract.
10, and this meant 1. That's the only symbols they had. So what the hell? What the hell? Stay with me now. So let's build this up now. So what number would this be then?
12.
12. I love it. Because there's only one place. It's in one place. There's no space in the middle. I'm not in the next place up. I'm still in the ones place. So they had several symbols all in one place. Do you guys understand this so far? I mean, that would be 12. Why is that 12? Because it's a 10 and 2 ones. So that's 12. Let me stop there for a second.
So why is there one underneath?
Sorry. I drew that in later. And that's because I wanted to make sure you guys understood. I'm still in the ones place.
Yeah.
There's no space. I'm not also in the 60s place or something.
right.
This is all in the ones place. Now, the other thing then is, when do I have to then use the next place? So how, for these two places, if I start at 0, 0, and then 0, 1, when is this going to become not 0 anymore if I keep adding 1?
60.
The minute after this is what? The next one is going to be 1, 0 after this is?
59.
Well, okay, for Babylon, I'm with you. For our system, it'd be 9, right? And then we got to switch over because our base is 10. So I want to go up to 9 because then the next one would be one of these, 0 of those. 1, 10, no 1s. So we're going to always switch when we hit our base, right? So for Babylonians, they would go 0, 0, 0, 1, up to 59. Because how would they represent the number 60?
1 in the second place.
So Babylonians have place 1, place 60. So if they want to represent the number 60, how many 60s do they have? 1. And then none of these, right? You guys kind of with me? So their 1, 0 would actually mean 60. If only they would have had a symbol for 0. They didn't have a symbol for 0.
What?
Totally. Now again, you guys were born at a time after 0 was invented. So you don't even realize 0 had to be invented. In fact, the minute I said that, you're all like, some of you guys were like, 0 had to be invented? Who are these people? People that were born before the freaking thing was invented. So everything that's been invented, you were born into it. You can't even imagine life without it. I remember getting up to turn on TV. Where, oh shit, turn on TV. Right, we didn't, and then I remember when remote controls were created. Holy shit, I'm that old. And then we're like, oh, this is neat. I don't have to get up. And then we all got a little fatter. And then the next thing was invented. We all got a little fatter. It's crazy.
Was zero a thing when you were a kid?
No. Yeah.
How old is it?
The Babylonians and I, we were out there planting crops. We created chicken nuggets, actually. So you should thank us. Yes.
Getting your hands cut off from Hammurabi's code and all that kind of stuff.
Thankfully,
What's better than you?
that didn't happen to me. Some friends of mine, yeah, when I was really young, about 1,000 years ago. Let me see. So does it make sense so far? The symbols and then the places. So what's the number 59 look like in Babylonian? So this is Hindu Arabic. If I want to change this to Babylonian.
5 of the less than
5
things.
4.
Yeah, good. 5 less thans.
And then 9 ones.
Now that's...
6 less thans. And then...
No, hold on. Well, let me tell everybody else. Well, Mr. Read Ahead, which I love, by the way, but hold on. So thankfully, the Babylonians, they also invented some rules so that they don't have to write this many freaking symbols, right? Because you can imagine these people had to pound them into these clay tablets. This guy's like, please, dear God. This guy keeps wanting 59. There's got to be a better way to do this shit. So what they invented was one more symbol. They invented the symbol this, which means minus. So another way, so to write 59, I could write it this way, or I could write it as 60 minus 1. Which is a little bit better than that, right? So if I want to write the number 19, I'd write 20 minus 1. You guys with me so far? So we're still just dealing with the first place. We haven't gone into the second place yet. Okay.
So they don't stack the symbols?
Say one more time.
They don't stack symbols?
We're not going to get into the point. There's a lot more to each of these civilizations than we're going to get into. So there, for example, the Egyptians had a lot to do with fractions and making mathematics easier. We're not going to get into all that. The Babylonians did have stacking, and they did do some other things with their numbers. We're not going to get into
How do I
that.
distinguish though between each place?
Space.
You just
So the fact that they didn't have the number for 0, a symbol for 0, makes for interesting interpretations of numbers. So if you wanted to tell somebody to bring 403 chairs, they might bring 43 because they're like, well, you said 43. I put space in the middle. No, come on. Do you see what I'm saying? They didn't have a symbol for 0, so they couldn't represent an empty place.
right.
Cool. In fact, they invented the idea of 0, and then their civilization fell. They're like, hey, look what oh, shit. I made 0. Nobody's around to watch. Right?
They divided by 0.
What's up?
They must have divided by 0.
Oh, poor guys. maybe, or they ate a bad nugget. I don't know. All right, so it's always easier to go from somebody else's number system back to ours. So let's start there. So let's see if you guys get this. So if I had this, how many places do I have to assume is up there? Two, because I see one space, so there must be 2 places. So what place is this in? The ones, and this is in the 60s. So all you got to do is interpret what their symbols mean, multiply and add. You guys see what I mean? How many 60s did it have? 11. So this is 11 60s plus 23 ones.
So then how do you write anything that's divisible by 60?
As a 1 in the second place.
If you want to write 120, you would put a 2, but you're right, there's no symbol for 0.
Yeah.
So you would add 1 to it, just to be on the safe side.
That's it?
I don't know. That's what I would do if I was in that time. If I was an educated Babylonian, because you'd have to be educated in the first place to know what the hell anything is, I would have done that. Why not? If you want an empty space, we need 200 chairs or 120 chairs. Let's get 121. So we'll have an empty chair. Who gives a shit? At least we have more than 12, right? Do you see what I'm saying? Or more than...
I mean, is that actually in practice?
I have no idea. So it could be a research project for you to go find out.
Find the time machine.
It's very difficult to find certain things out because there weren't necessarily records kept of things. And if they were trying to say, when I write this, I really mean this, what would they write on the second line? Do you see what I'm saying? When I write 121, I really mean, it's like, well...